Section 3.4 is on graphing linear systems. So we have been working on linear equations that just have an x and a y in common. These are going to have regions in common. And it's very important when you do this that you use colored pencils on it, using a colored pencil for each different equation so that you can graph it and find the area they have in common. We're going to take this and we're going to apply it to something else. So if you'll follow the instructions now, it will save you in the future. So the very first thing I have to do, of course, is put this in y equals mx plus b form. So I have a negative 2y is greater than or equal to negative x minus 2. I'm going to divide by the negative 2. So that's going to change the direction of my inequality. It's going to make this 1/2 x. And it's going to make this plus 1. So I want to graph that over here on my graph. And we will do that, but in the meantime, we'll solve the other one. I'm going to take the x over, so I have y is less than or equal to negative x minus 1. So one of these I'm going to do in blue, and one of these I'm going to do in red. So I'll keep it color coordinated. I have a y-intercept of 1. I go up 1 and over to the right 2. Notice how there's a line underneath it. So this is going to be a solid line. And I'm going to notice that I'm going to shade underneath this line. Okay, so I can put some shading in there, but I want to do it real light so that I can still see to graph my other equation. So my red equation, I have a negative 1. And I'm going to go down 1 into the right 1. It too has a line underneath it, so it's going to be a solid line. If there wasn't a line underneath it, it would be a dotted line. So this one is less than, and this one is also less than. So if you'll notice, if I'm going to graph less than this, then the area that they have in common is going to be that area right there, okay? And that's what you're looking for, is you're looking for the area that it has in common. So let's do another one of those. All right, I've got two equations here. It's already in y equals mx plus b form. So all I have to do is graph it, and what I'm going to do is I'll put a green dot there and I'll put a red dot there, so I have it color coordinated. On the red one, I'm going to go down 1, and then I'm going to go up 2, so 1, 2, and over to the right 1, 2, 3. Notice now it is a dotted line because there is no line underneath the inequality. And I would actually shade that below the line. Okay, my green, I'm going to go up 2. I'm going to go then turn around and go up 2 and over to the right 3. Notice how these are parallel lines. Again, it's a dotted line. And that one, I'm going to shade above the line because it's greater than. So the area that they have in common is nothing. This is empty set. You're going to have some that are going to do that. Let's do another one. Okay, now these are a little bit harder. This one, I have an absolute value, so remember that actually translates into x minus 3, and x is greater than negative 3. So we'll do that, those two in green. We'll do this one in red. And we'll do this one in blue. Put these on here and see what they have in common. This is going to be a bounded region, which means I'm going to actually make a enclosed figure inside it. I'm not going to shade it until the end so that you can see it. So this is x is less than 3. X is less than 3. It's a dotted line through x equals 3. It's a vertical line. Okay, and it's going to be shaded left because it's less than, but we're going to keep that in mind for a minute. This one's going to be a dotted line through x is equal to negative 3. And it's going to be shaded right because it's greater than that. So right now we're talking about this area right here. So I'm going to go on and graph my other 2. I go down 2. Then I'm going to go up 1 and over 1. It is a solid line. And right now it would be above that line. So right now I've got all of that space right there. So in blue, I'm going to go up 4. Then I'm going to go down 1 and over to the right 1. It is a dotted line. So if you will, and it's less than that. So right now, I'm going to shade it, and you're going to see that all this area in here is what they have in common. So literally any ordered pair that you would see in that shaded region would fit in one of those equations. All right, so we're going to do this one. I don't have a coordinate plane because this is going to be a little bit bigger. So let's go ahead and solve them, and then we'll graph it out. So I have a negative y is less than or equal to negative x plus 7. Y is greater than or equal to positive x minus 7. So that's going to be my one equation. This equation, I'm going to subtract the 3x. I have a negative 3x minus 11. I'm going to divide by the negative 11, so it's going to switch the direction of the inequality. So I have 3/11 x and plus 1. And then this one might be easier. Let's see. So I have y is greater than negative x minus 1. So there's my 3 equations. Sometimes you have more than 3 equations. I'm going to freehand this, so it might not be exactly straight. Okay, so let's do blue, green, and red. And so the blue one, I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 1 and over to the right 1. It is a solid line. And it would be shaded above that line. The green one, I'm going to go up 1, but then I'm going to go up 3. 1, 2, 3, and over to the right 11. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. So approximately right there. It is also a solid line. And it's going to be less than that. So right now I'm in that area right there. And then your red, you're going to go down 1. And then you're going to go down 1 and over to the right 1. Obviously graphing is a very important thing in this. And it's going to be greater than this. So the area that is bounded is that area. Now, we are going to, in class, learn how to find these vertices, these points where they cross. But that's going to be for another day. We're going to use that in linear programming. So your homework for this section is page 151, 14 through 26 even.